atomic radius or the atomic size. So what does mean by the atomic radius or the atomic size? As the name is going to show, the atomic means it is related to the atomic, and radius mean it is the radii of the atom or the size of an atom. So let's start the introduction of atomic size. Basically, the atomic size, it is the size of an atom, and the size of an atom that we see, size of an atom, it is not rigidly fixed. It is not rigidly fixed, but it varies when combined with different atoms. So basically, the atomic radius by definition is the distance between the nucleus and the valence shell, between the nucleus and valence shell, or we can also write that the outermost shell of an atom. This is termed as the atomic radii. This is known as atomic radii or the atomic radius. We can also say that it is the atomic size. And the atomic radii, it is represented by the small r, and it is directly proportional to the number of shells. It is directly proportional to the number of shells. So size of an atom is directly proportional to the number of shells. If we have more number of shells, or if the shell number is going to increase, shell number is going to increase, in turn the atomic radius or the atomic size is also going to be increased, because they have direct relation between the radius and number of shells. So the atomic radius is mostly the unit that we use to express, it is the nanometer. Nanometer means 1.0 into 10 raised to power minus 9 meter. Minus 9 is going to show the nanometer. So this is a simple introduction about the radius or the atomic size of an atom. Next, we have trend of atomic size in the group or in the periodic table. As the periodic table has been divided into groups, so groups, when we move from top to bottom, we have a change in the atomic size. The first one element is in the group 1a, hydrogen. It is having only one shell. When we are talking about the second element, it is lithium. It is having total two shells. The third one element is sodium. It is having total three shells, or we can say that three orbits. When we are talking about the fourth one, it is potassium. It is having total four shells. So when we move from top to bottom, as there is increase in the number of shells, there is increase in number of shells, so there is also increase in the atomic size, because in the previous relation we have learned that the radius or the atomic size is directly proportional to the number of shells. So this is the trend. When we move from top to bottom in the group, the atomic size of an atom is going to be increase, because, and the reason is, the number of shells are going to increase. And the next, we have the trend of atomic size in the periods. When we move from left to right, we are going to talk about the periods. So in the first period we have hydrogen to helium. In the second period we have from lithium to neon, and in the third period we have from sodium to argon, and in the fourth one period we have from potassium to krypton. When we move from left to right, as hydrogen its atomic number is 1 and helium its atomic number is 2. Lithium its atomic number is 3 and neon atomic number is 10, and sodium its atomic number is 11, and for argon we have atomic number 18. So when we move from left to right, there is an increase in the atomic number, but along with this, there is increase in the charge on the nucleus. Charge on the nucleus mean there is increase in the nuclear charge, and that nuclear charge is in the positive manner, as the number of protons are also going to increase in the nucleus of an atom. And when there is more nucleus in the atom, then it will pull the valence electrons more tightly toward itself. In turn, the size of an atom will be decreases. It's mean when we move from left to right, the size of an atom is going to decrease. And why the size of an atom is going to decrease? Because there is more nuclear charge. When nuclear charge, or we can say that the positive charge is going to increase, then the atomic size will decreases or move downwards. So this is the simple trend of atomic size in the periods of the periodic table. So I hope you guys understand about the trend of the atomic size in the periodic table in groups as well as in the period. And if you have any queries, you can ask me about that in the comment section. I will get back to you guys soon, inshallah. For that time, have a good day and Allah Hafiz.